Okay, without any further ado, Dr. Terry Root, thank you so much.
Thank you. Let me now switch over to my screen. There we go. Does that look okay? All right, good. Well, first of all, I want to say thank you very much for inviting me to give this talk. It is my passion to try and get people to become aware of climate change. And the thing that is really true about climate change is it is going to be a huge disaster unless we do something. And that's the good news, is there's a lot of things that we can actually do. A lot of things that we can do to avoid the disaster, and all we have to do is just get off our duffs and do it. And that's one of the reasons why I go around giving so many talks, is to try to tell people that you don't have to change your whole lifestyle horribly. You just have to make a little tweaks here and there, and we'll talk about that. So just to give you a little bit more information about me, I was a professor at the University of Michigan, and then I went to Stanford and was there for quite a few years, almost 20 years. And I also worked on the Intergovernmental Panel for Climate Change. And I worked on the 3rd, 4th, and 5th assessment reports. And it was a lot of work. It was all volunteer. It was some of the hardest work I've ever done in my life, but it was some of the most rewarding too. So I know that when we're in the middle of a pandemic, it's hard to think about other traumas, but we do still need to think about climate change. So let's get started and talk about climate change. What I want to talk to you about today, I've got to figure out now how to advance the slides. There we go. Okay, this is what I want to talk to you about today, is climate change since the early 1900s. Excuse me a minute. Sorry. I'm saying since the early 1900s because before that, humans were not affecting the climate. After that, humans have been affecting the climate. So throughout the talk, I'm going to be talking about temperature change above natural. And when I mean natural, I mean what it would be if humans were not actually affecting it. And the way we figure that out is we look at what the temperature was in the late 1800s, early 1900s. So the shift there between 1800s and 1900s was a very important one as far as climate change goes. So then after I've talked about climate change since the 1900s, then I want to talk about future climate change. Now, I don't have a crystal ball, but we do have different scenarios of what may be going on. And I'll talk to you about some of those. Then being a biologist, what really got me into this business was what was happening to other species. And that's what I want to talk to you about today a lot, is about what's going on with other species, because they are having trouble and we need to be talking about that. Now, I want to put in a warning here. Section 1, Section 2, and Section 3 of this talk are going to be pretty depressing. Now, if you'll hold on and not get too depressed and wait until Section 4 is what we all must do. And that is very uplifting because there's a lot of things that we can do. So please don't get too depressed in Sections 1, 2, and 3. I know it can be pretty tough to hear all the doom and gloom, but we'll come back in Section 4 and change that. Now, for the bird watchers that are watching this, this is what I call my roadmap slide. And all of my roadmap slides, there'll be 4 of them, will have a different bird on them. And these birds are currently, they summer in Sarasota County. And with climate change going up by 3 degrees above natural, these birds that are on my roadmap slides will no longer be able to be in Sarasota County. It will be just plain too hot for them. So keep an eye out for the birds that you'll be seeing. Now, let's switch gears now and let's talk about climate change since the 1900s. Well, the first thing we have to do is talk about abnormal things that have happened. And a lot of abnormal things have happened to our climate in the last year. So in August 16th of 2020, we had the most reliably recorded hot temperature, the hottest temperature that was reliably recorded on Earth. And this was 130 degrees Fahrenheit. And that is cooking, literally cooking. At 104 degrees Fahrenheit, enzymes start denaturing. So you get up to 130 degrees Fahrenheit, then you're cooking. And for humans, it's okay. You can go in the buildings and turn on your air conditioner, go in your car and turn on your air conditioner. But think about what's going on for these poor plants that are having to sit out in the sun. They literally are cooking. The poor animals that are sitting out in the sun, they are literally cooking. So this is a tough thing to have happen, but we're going to have more hot times coming up. Another unusual thing that happened was in February of 2021. I'm sure you all remember this, when Ted Cruz took off and went down to Mexico. It was such a big deal with the news. It was a bigger deal with the news than what was actually going on with the climate. But if you look at what's going on with the climate, you had freezing rain going all the way down to the Gulf Coast. And this was highly unusual. And this is exactly due to climate change. There are a lot of politicians that will say, well, if it was so cold, why in the world do you call it climate change? Well, I can talk about why climate change is causing this, but the bottom line is we are warming up the Arctic. As the Arctic warms up, the jet stream that is around the polar vortexes switches around and comes down farther south. And that's what's happened. And it is this type of an event that we should be expecting. It's going to become the normal, abnormal for our winter times. Another thing that happened on Friday the 13th, I've got a kick out of the fact it was Friday the 13th in 2020. We had the 30th named storm in our hurricane season last year. That was the most named storms ever recorded. And now we have an early storm. Anna has already been recorded. The last 7 years, we have had named storms recorded before June 1st. I think they're going to have to shift the timing of the hurricane season to be in middle of May instead of the 1st of June pretty soon. And that too has to do with climate change. And then the tornadoes. Tornadoes, this was very, very early tornado that was happening. They're happening in the southeast US, and it is very unusual for them to happen this early. And again, this has to do with climate change. And again, this is our new normal abnormal. These kind of abnormal weather events are going to be occurring more and more often. Now let's talk about global temperature. And what I'm showing you here is global temperature relative to what the temperature was before humans started affecting it. And the plot goes in a circle from January all the way to December, and it goes by year. And you can see now in the 90s, it's getting warmer and warmer and warmer, and all the way out to almost 1.5 degrees Celsius above the average from 1850 to 1900. So you can see that it is getting warmer. In the early or the late 1800s, it was fairly cool. It still is fairly cool up to the 30s, the 40s, the 50s. It really starts getting warm in the 70s, the late 70s and on up. So that is actual temperature. And since it only went to the 2017, I wanted to show you that if you continue on out, it still is getting warmer. So this is by decades. And the 2010s, we're up to 1.2 degrees Celsius, which is 2.2 degrees Fahrenheit above natural. That is really quite warm, and that is something we need to be concerned about very, very, very much, because 1.2 degrees Celsius above natural, I'll show you, is something we have to slow down. Now, what has gone on throughout the whole United States? This slide on the screen right now is talking about the world. Let's talk about just the United States. Since for the last 51 years, basically, Earth Day occurred in 1970. So the warming in the United States since the very first Earth Day has been 2.4 degrees Fahrenheit. So over that 51 years, that's how much it has actually warmed. Now, what's gone on in Sarasota? Well, surprise, it's gone exactly what the average was for the US, 2.4 degrees Fahrenheit warmer. That warming now has come from winter warming. Here is the average winter temperature in Sarasota, again, since the first Earth Day, and it has been up by 3.6 degrees Fahrenheit. This goes up to 2020. And now we look at the warm summer nights, and this is where we have been getting most of our warming, is the warm summer nights. The average low temperature has shot up 5.4 degrees Fahrenheit since 1970. So between 1970 and 2018, we have warmed by 5.4 degrees Fahrenheit. That is a lot of warming, a lot of warming. And that helps explain to some extent why my husband and I don't leave the windows open in the middle of the summer anymore. Now, when the world starts warming, what happens is ice starts melting. And here's the Columbia Glacier in Alaska. And you can see how it has melted since 2009 up to 2015. Excuse me again. Excuse me. And you can see how much the ice has actually melted. And this has gone on. Most of the glaciers, basically 98% of the glaciers around the world, have been receding. The ones that are not, there's explanations for that, and I can go into that if you would like to know that. But what I would like you to do now is understand that the globe is truly warming. And when it's warming on the land, it's also warming in the oceans. The water is warming. And here is the change in heat content of the oceans. This is relative to 1981 to 2010 averages. And this is in zettajoules. And you can see how much it has actually warmed. There's a lot of warming going on in the oceans. So now what I would like you all to do right now is make a pact with me. I want you to never, ever again to say that you believe in global warming or that you believe in climate change, because it's not a belief, folks. What it really, truly is a fact. The globe is warming, the climate is changing. So we really do need to not say it is a belief, but it is a fact. So if someone walks up to me and says, Terry, do you believe in global warming? I say, no, I know that the globe is warming because it is a fact. We have looked at the thermometers and we know that. Now, where has all of that warming come from? That has come from CO2 concentrations in the atmosphere. And we have information going back 800,000 years from now. And now literally means an hour before this talk, because I was able to get on the Bloomberg Carbon Clock. It's a website, Bloomberg Carbon Clock, and it will tell you what the carbon content is of the atmosphere at that moment. And at that moment, it was 417.3 parts per million of CO2 concentration in our atmosphere. And if you can look at this plot, On the x-axis is time. It goes from now on the right-hand side and goes backwards in time to 800,000 years ago. And during that time, the CO2 concentration in our atmosphere has never been above 300 parts per million until basically now. So since around the 1960s, a little bit before the 1960s, humans had put so much CO2 in the atmosphere that it has changed the way that our Earth retains heat, and it has caused the warming. But now we are actually up to 417 parts per million, which is quite high. Now, that's not coming from around the globe evenly. If you now look again, on the x-axis is time, on the y-axis is gigatons of CO2, and there's a little e, and that stands for equivalent. And what that means is it's gigatons of CO2 plus other greenhouse gases. So what it should say is gigatons of greenhouse gases, but that's too long to say. So they say CO2 equivalent. And you can see that China is very, very high. The next country is the US. And the US is quite high, particularly given how many people we have. And I'll show you a plot of that. But if you go down and you look, you have China, US, the EU, then India, Russia, Japan, international transportation comes next, and then global. So anyway, China is quite high and America is also. But now let's look at it per capita, and that changes all the arrangements of the countries to this. America is up on the top. Now, that's not good because we need to be doing better. But what is good is that means we can do better. And I'll be talking to you a lot about what we can do to change that in America. And by changing what we do in America, will make a huge difference. If they changed what they were doing in, say, the EU, it's not going to make as big of a difference as it would as though we change our habits in America. So now you have the US, Russia, Japan, China, EU, the world average, and then India is down below that. So this is a positive plot, in my opinion, because we in America now can make a big difference. We can take over the leadership role and go for this and make a big change. Okay, so that's talking about climate change since the early 1900s. Now let's switch gears and talk about future climate change. And here's one of my roadmap slides, the red-headed woodpecker. I actually have a red-headed woodpecker coming on my property right now. I live off of Fruitville, just on the other side of I-75. And we have got red-headed woodpeckers. As the climate warms, the red-headed woodpeckers are not going to be able to survive in Sarasota County. They will be pushed out, and I'll show you an example of that later. Okay, so future climate change. Now, the Intergovernmental Panel for Climate Change, which is made up of over 2,000 scientists from around the world, get together about every 6 to 7 years and say, okay, what's gone on? What have we learned in that 6 or 7 years since the last one? And what do we need to be telling policymakers? Well, in 2016, they came up with this plot, and they said, let's think that we have different scenarios. We don't know what's going to happen in 2100, but if the world continues as it has and stays business as usual, we will be on this black line. So on the x-axis is years, and on the y-axis is CO2 equivalents. So again, this is parts per million of greenhouse gas concentrations. And if we do business as usual from 2016 on, then we are going to be up to about 1,300 parts per million of greenhouse gases in our atmosphere. Holy mackerel, we can't sustain that. That the temperature for that is going to be astronomical. We can't do that. The suffering and trauma is going to be way too high. So another scenario were the blue and green curves here. And what that shows is more egalitarian communications among countries. So they will share research and they will share technologies, and people will work together to try to bring down the greenhouse gases. There's some difference between the blue and the green curve. I don't really want to go into that differences, but it suffices to say that if we start working together, we can really make a difference. And coming down to the blue or the green curve would make a huge difference compared to what we do if business as usual. Now let's look at the red curve. The red curve scares me to death, because what the red curve is the scientists in 2016 said, let's stop all greenhouse gases from being emitted into our atmosphere. So it's as though God flicked her fingers and said, stop all emissions of greenhouse gases into our atmosphere. Well, if you do that, you would assume that the parts per million in our atmosphere of greenhouse gases would plummet. But it doesn't. It actually continues to go on up and on up until you hit about 2050. Then it comes down very gradually. Why in the world doesn't it come down right away? Well, CO2, not the other greenhouse gases, but CO2 stays in our atmosphere for about 1,000 years, actually a little bit longer, but around 1,000 years. So that says what we do today, the CO2 that we put into the atmosphere today will be in the atmosphere for 1,000 years. 1,000 years is about 40 generations. So that's saying that what we do today will affect our great 39 greats grandchildren. That's a very sobering thought, but that's a very positive thought too, because that means we can make a big difference, because what we do today is going to actually change what will happen in the future by a lot. This is also telling us, this red line is also telling us that CO2 comes out of the atmosphere very, very slowly. And the main way that it comes out is by being absorbed by our vegetation, by trees. That's the main way that it comes out. Technology is not there. I'm not sure it's going to be there anytime soon to actually get the CO2 out of the atmosphere. We've got to do it with plants. So one of the things that we need to be doing is planting more trees, but we'll get to that in a minute. Now, this is a plot like I showed you before. It's a change in temperature relative to the average from 1850 to 1900. The only difference is these are not actual data. These are modeled data, but they come very, very close to what the actual data are. But these go all the way out to 2100. And this is assuming we are on our business as usual curve. So if we go out to 1,300 parts per million of CO2 equivalent by 2100, we will have the world going up by 5 degrees Celsius. Holy mackerel. We just can't do that. That is going to be astronomically difficult. The sea levels are going to go up. It's just going to be horrific. The growing crops is going to be almost impossible. That's a tough one. We don't want that to happen. We have to stop it. We don't have a choice. We have that obligation to future generations. So let's talk a little bit about sea level rise. That's very important to us here in Florida. So in 2018, we knew that the sea level has increased by 8 inches since 1880. So in the time period that humans have actually been affecting the climate, we have increased the sea level rise by 8 inches in 2018. Now, what about what happens in 2050? Assume the person that is looking here out at the ocean is 6 feet tall. The best estimate for 2050 is going to be 31 inches higher than it was in 1880. So this is due to human causes. And this does not take into account storm surge at all. It is just sea level rise. Sea level rise comes from, as you heat water, it expands. So it has to, it gets bigger. So it comes up on the shores higher. And also it has to do with all the ice that is melting from the glaciers. Now the iceberg that just broke off of Antarctica is not going to increase the sea level rise at all, because that was actually floating ice. It was not on land. So ice will only increase sea level if it is on land and then it goes into the water, not ice that is resting on the water. But now what about in 2100? This is a tough one. It is very hard for us to understand how water melts. I know that sounds funny, but having glaciers melting, it is a really tough thing to calculate. We just learned that the ice sheet in Greenland has water underneath it. So as the water melts, it drops down to the bedrock, and now that water is acting as a skid to help the ice flow out. So modeling water melting on ice caps is a very difficult thing to do. But our best guess for 2100, our best guess is 9 feet. 9 feet of sea level rise by 2100. Holy mackerel. That is a lot. So I plotted it up. This is what in Sarasota will look like if you have a house on Coquina Beach, Longboat Key, Bird Key, Lido Key, Siesta Key. They're going to be underwater. And a lot of Sarasota, the infrastructure is going to be underwater. Van Wezel will be underwater. It's going to be tough. It's going to be really tough. So yes, I live on the other side of I-75, so my house is not going to be affected, but the people that live there will be, because the infrastructure, there are hospitals that are going to be gone, post offices that are going to be gone, banks that are going to be gone, county buildings are going to be gone. It's going to be a big change, a big change. Now, about 3.5 months ago now, maybe 4 months ago, there was a study that was done of the Greenland Ice Sheet, and it came out and said that we have passed the tipping point of melting of Greenland. So Greenland's ice sheet is going to melt. There's nothing we can do to stop it. It's irreversible. We are melting Greenland. So Greenland has between 27 and 29 feet of sea level rise in it. So now if you look at Florida, that's what Florida will look like with 28 feet of sea level rise. Now at the exact same time that the sea is rising because of Greenland melting, Antarctica is also going to be melting, and Antarctica has a lot more than 28 feet of sea level rise in it. But I was talking about Greenland earlier, about how we've passed the tipping point. That's why I focused just on Greenland. But now even my house is no longer safe with that. Okay, that's the future of climate change. Now, let's talk about other species. Now, I was lucky enough in I think it was 94, my late husband and I were able to take a Russian icebreaker up to the North Pole. And my husband took this picture. It is of a polar bear that has just had a brand new seal kill. That's a hard thing for me to say. And when polar bears out on the ice would find seals, they would catch the seals from the hole in the ice, and they would fling blood and guts literally all over the place. And this little bird right here, I hope you can see it, is an ivory gull. And the ivory gull makes its living by scarfing up all the blood and guts that the polar bear leaves behind. Now, when you don't have any ice, you don't have polar bears going out on the ice to kill the seals. That's great for the seals, bad for the polar bears, and astronomically, horribly dramatic for the ivory gull. And what has happened now since, since about 2000, the ivory gull population has been plummeting. And if I have a normal lifespan, I'm 67 right now, if I have a normal lifespan, I will bet you $1 million that the ivory gull goes extinct before I die. That's a very, very sad statement. So the ivory gull on my watch will go extinct. And that I have a lot of trouble with. But what this slide is showing you is how when you have one animal being affected, like the polar bear, it's affecting two others in this picture, the seals and the ivory gull. Now, biology, all of the species are interwoven in a web of life. And so if you push on one species, a whole bunch of other species get affected. That's what I'm trying to show you here. And that is what we are actually doing right now. Now, species can adapt. Here is a shot of the cherry blossoms in Washington, D.C. And the cherry blossoms usually will bloom, oh gosh, I don't remember the date now, in late March. I think it was in late March. Well, it's not late March, it's not at that time anymore. It is now earlier and earlier and earlier and earlier. So each year they're having to have a celebration of the cherry blossoms that is happening earlier. It's true in Washington, D.C. It's true in Japan, where we got these cherry trees from. So animals and plants are doing things earlier in the spring. And we all know that. Our daffodils are coming up earlier. Our fruit trees are fruiting earlier. Birds are coming back earlier. They're having baby birds earlier. A lot of things are happening earlier. And that's to be expected as we have more and more warming. The other thing that is happening with species is they are changing their ranges. Their ranges are moving. They're moving to cooler areas. So in the Northern Hemisphere, you go up in elevation or towards the North Pole. In the southern areas, you go up in elevation or you go down towards the South Pole. And that is exactly what plants and animals are doing. We're tracking it. Now, in 1985, a colleague of mine at Princeton did a study in Peru of a Peruvian mountain that was 14 meters tall. And he found that the common scale-backed antbird went up to about 800 meters. Then the versicolored barbet went up from that location up to a little bit more than 1,200 meters. And up at the very top of the mountain was the variable ant shrike. Now, he kept meticulous notes on where his transect was. So a lot of students went in 2017 and redid that exact transcript and found that, yes, the species are doing exactly what we expected them to do. They're moving up where it is cooler. The common scale-backed antbird now isn't stopping at 800 meters. It's going all the way above 1,000 meters. And the versicolored barbet is now going all the way up to the top. Oh my gosh. Now what's happened to the variable ant shrike? Oh, it's popped off, completely popped off the top of the mountain. There's no room for it at all. It's too warm and there's too much competition going on. So both things are happening. And now the variable ant shrike is now no longer on this mountain in Peru. And that is what we are finding all over in the US, all over. It's happening. So the birds that are being affected the most are the ones at higher elevation, or all plants, not just, or all animals and plants, not just birds. Now, Audubon did a study, it's called Survival by Degrees, and you can go on Audubon's website and look at this. And what they have found is that there are 389 birds of all of North America's birds that are on the brink of extinction. That's a very, very sobering thought, because that's 2/3 of all North American birds are on the brink of extinction. Holy cow. That's a lot of birds that may go extinct due to just one species, and that species is us. So we need to do something, keep those birds from going extinct. Now you can go on Audubon, it's called audubon.org/climate/survival by degrees. And you can put in your zip code. This is exactly what I've done. Put in a zip code for wherever you want to be looking. And it will tell you about the birds that occur in your region. But now let me show you, I've done that for Sarasota. Let me show you what I found. They looked at more than 140 million observations in this study. It's a huge, huge study. They've also looked at all the climate variables, all the human land use variables, vegetation variables, and then the thing called group specific variables. And this is a picture showing you what they would use if they were looking at water birds, for instance. And now they have been able to predict what is going on at a 1 kilometer square resolution. So they can literally do it by zip code. It is a very, very impressive piece of work. So let me show you what they found. Here's the red-headed woodpecker, and this is the current summer range. And you can see it occurs in Sarasota. As I said, it's in my backyard. Now, if the planet were to warm to 3 degrees above natural, which is 5.4 degrees Fahrenheit above natural, this is what the range of the red-headed woodpecker would be. 94% of its current summer range would be lost because it would be too hot. 6%, only 6% of its current range would be stable. It would move farther north if habitat were available, and it could gain up to 33%, assuming that the habitat is available. This is for 3 degrees Celsius above natural. Now, what happens if we only look at 1.5 degrees above natural? That is what it looks like. A huge, huge change. Now we only lose 44%. We still will lose it here in Sarasota, but we won't lose it in Atlanta, Nashville, Raleigh. All of those places will still hold the red-headed woodpecker in the summer. 56% of its range will be stable. That means it has a much higher probability of being able to not go extinct, to withstand the extinction push. And 25% of the range will be gained if that's possible. So what we want to do is we really want to stay at 1.5 degrees Celsius, which is 2.7 degrees Fahrenheit above natural. We don't want to go higher than that. Now, plants and animals are able to change. They move around, but the problem is that now we have a scarred landscape for them to move across. Consider what you would think if you were a butterfly trying to cross across a cityscape like this. Very, very difficult thing to do. And there have been species of butterflies that have been down in Baja California. They've moved north. They've run into Tijuana and San Diego, and they haven't been able to get across it, and they have literally gone extinct. They have already gone extinct. 2 different butterflies have had that happen. So what we need to do is we need to make these cityscapes more species, wild species, make it so that they can use the area in the cities. So make them more friendly. And the way to do this is plant native plants. So I'd like you to make another pact for me today. And that is to never, ever, ever again plant a non-native plant again in your yard, unless you're going to eat it or unless it's a fruit tree or something like that. But if you're going to have a veggie garden, that's different. But when you're putting in plants, we don't need more Scheffleras in Florida. We truly, truly don't. We need more milkweed for the monarchs. The monarchs are dropping in abundance because their food source isn't available. Well, plant a milkweed instead of planting a Schefflera. Now, we need to know what plants are native in our area. Well, Audubon has done that for us. Audubon.org/plants for birds. You type in your zip code and up will pop a list of all native plants in our area. Or you can go to a native plant nursery. There's one out on, you go to the end of Fruitville and you turn right, and I don't remember the name of the road, Velma or something like that. And there's a native plant nursery there. There's also a native plant nursery in, I'm having a senior moment, folks. I don't remember the name of the town. It is just north of us. It's not Bradenton. It's, shoot. Anyway, I'm sorry, I don't know. But anyway, you can find native plants for species, but please, please make a pact with me today. Don't plant any non-native plants for species. We don't need any more Scheffleras, because what's happening is by planting more Scheffleras, species are going extinct. They can't get across our cities. If there had been food plants for those butterflies planted in Tijuana and San Diego, they may still be alive and not extinct. But we do need to talk about extinction. There is background extinction rate. Background extinction rate is measured by biologists as less than 1 species in 1,000 species over 1,000 years. So if you have 1,000 species on a big, huge island and you watch them for 1,000 years, less than 1 species will go extinct. Now, let's talk about what the current extinction rate is. And I've had to change this slide many times. It's about 1 species in 10 species, not 1,000 species, over a little bit less than 100 years, not 1,000 years. So that is pretty fast. 4 orders of magnitude is what's happening. And that is caused by 1 species. That 1 species is us. And I'm not sure that that is correct morally. We need to really do some soul searching on that one. Now, the IPCC in the 4th assessment report in 2007, we said that if it goes up by 2 degrees Celsius, which is equivalent to 3.6 degrees Fahrenheit, we could lose about 500,000 species to extinction. Now, we know the names, or we have defined the names of about 2 million species on the planet. That's what we're talking about, is the 2 million species. There's probably between 8 and 10 million species on the planet, but we only have names for 2 million of them. So what that means is if we go up by 2 degrees Celsius above natural, we could lose a quarter of the world's species. Now, what the assessment report also says is if we go up 4 degrees Celsius or 7.2 degrees Fahrenheit above natural, we could lose 1 million species to extinction. That is half of the world's species, half of the world's species. I guarantee you that in even the quarter of the world's species that go extinct, some of those species will be species we need to stay alive. Our pollinators, species that clean our water, species that clean our air, species that help us grow our food. There are going to be species in there we are going to lose, and we absolutely need them. Also for medicines. So we don't want that to happen. We do not want to go up above 2 degrees Celsius because we can't lose that many more species. We just can't. So now I warned you at the end of the first, second, and third, we would all be depressed. But now let's talk about what we all must do. The first thing that we have to do is we have to have a paradigm shift. And having a paradigm shift has happened many, many times in our past, many times. Here's an example. This was for World War I, and it says, food will win the war. We observe meatless days, wheatless days, porkless days. And it was patriotic to not eat meat. It was patriotic to not use wheat. We were saving the meat and the wheat for the boys over there because they needed that to win the war. And we saw it as patriotic. Everybody got on board. It was not a hard paradigm shift. We did it. We did it. We just had to have the political will, and we did it. Here's another example. Blow in her face and she'll follow you anywhere. This represents 2 big paradigm shifts, not just one. One is it is no longer socially acceptable to smoke in public. We did it. We had a paradigm shift. We got rid of smoking in public. The other paradigm shift here is, I bet every single one of you are sitting there thinking, if some man blew smoke in my face, there's no way in this world I'm going to follow him anywhere. So we've had women's lib. So that's been a paradigm shift. We can do this. We just have to have the political will to do it, and we can do it. It's not going to be a heavy lift as soon as we have the political will. Now, this is a plot that I think is one of the most positive plots that there is. I'm sorry the data are old. These are the latest data that they have provided. I just got this, I don't remember how long ago, about 6 months ago. They don't have anything newer than 2016. But on the x-axis is location, and on the y-axis is CO2 per person. And now you can see the average for the US is here in the middle, and Washington, DC, New York, California is quite a bit lower than that average. That is super, super, super good news, because that means that we know what to do to bring down the average per capita. Florida is doing a good job too. It's lower than the average, the US average. It could certainly be lower. I've been fighting with Florida Power and Light about solar panels on my house. We need to convince Florida Power and Light that solar panels on people's houses is the best way to go. That seems to be a heavier lift than I thought it would be, but anyway, we can talk about that. But look, here's Florida. Where'd my cursor go? There it is. Here's Florida. Here's Mississippi, right next door to us, basically. It's so much higher. So Florida is doing the right thing. We are lower. But then we have these three huge states over here, West Virginia, North Dakota, Wyoming. What do they all have in common? Coal. They are using coal to generate electricity. Wyoming is coming down a bit because they are using other things other than coal to generate their electricity. So this will be lower once I get newer data, but still it is exceedingly high, much higher than the average, much, much higher than California and New York. When I used to be in California teaching at Stanford, I would say, of all the Californians I know, none of us have never met a restriction or a regulation that we didn't love. Not true, but the point gets across that California understands we have to have regulations in order to have a sustainable Earth. And that's what we have to have. We have to have that. Now, in October of 2018, the Intergovernmental Panel for Climate Change scientists got together again and said, the planet's not listening to us. We got to get them to listen. So they came out with a report that said, we must limit global warming to 1.5 degrees Celsius above natural, or 2.7 degrees Fahrenheit above natural. Remember, the US was I don't remember what it was now, 2.5, I think, 2.3, I don't remember. We're getting close. We're getting close to this. And what the scientists are saying is that we need big, big changes. And the changes that they said we needed is that by 2030, we have to emit CO2, that the amount of CO2 we are going to need to be emitting in 2030 has to be 45% of what it was in 2010. Here is what it was in 2010, a little bit below 40 gigatons of CO2 per year. 2017, oopsie, we're going the wrong direction. By 2030, don't have much time, folks. We got to be down to 45% of what we emitted in 2010. And then they've continued to say by 2050, we have to be at zero or zero net emissions. That's going to be tough. We're a plastic using society, and plastic comes from fossil fuels. And for every pound of plastic we, excuse me, for every pound of plastic that we make, we put 6 pounds of CO2 into the atmosphere. So if we're going to be at net zero by 2050 and still be a plastic using society, we've got to come up with some way of having negative CO2 emissions. That's going to be a tough ask, but we got to do it. Now, what the scientists with the IPCC did was say, we're going to give you a recipe of how to do this. So what they said was, for the electricity market, the percent of non-biomass renewables are solar, wind, geothermal, hydro, and nuclear. And they said that by 2030, not very long from now, we have to have 48 to 60% non-biomass renewables going into our electricity market. And by 2050, we have to have from 63 to 81%. I showed this slide to the American Wind and Wildlife Institute, and the audience of about 300, 350, 400 people erupted into laughter. And I said, hold on, guys, this isn't a joke slide. And a friend of mine in the back stood up and said, Terry, that's impossible. America can't do this. We aren't on the way. We're not leading. We can't do it. Well, America may not be able to do it, but the rest of the world may be able to do it. We have got to do it. We have got to get non-biomass renewables up to scale. We've got to do it. And America can do it if we have a paradigm shift and we really push hard at having renewables. Now, people know that I'm a bird person. I was on the National Audubon Board for 9 years. They say, Terry, how can you have turbines? Because turbines kill birds. Turbines actually don't kill birds. The oil and gas companies want you to believe that that is what is happening, but it is not. What actually kills birds, if the oil and gas industry is really so worried about it, they would worry about feral cats. Cats kill birds. This is the number of birds killed per year by different things. 2.4 billion with a B birds are killed each year by cats. That includes the 800, this is in North America. That includes the 80 million feral cats in the US, plus there happens to be 80 million pet cats that occur in North America. All of those are not permitted outside, but even if a quarter of them go out go outside at all, a quarter of the 8 million pet cats go out, that's 100 million cats outside. That's a lot of cats. They're killing a lot of birds, particularly young birds. So then if you look at other things, birds running into windows is almost 600 million, being hit by automobiles, 214 million, running into power lines, 25 million, running into towers, 6.6 million, being electrocuted, 5.6 million. Here it is, the number of birds that are killed per turbine per year. So it's 234,000, 4 orders of magnitude difference. So on average, the small songbirds that are killed by turbines is about 3.5 to 3.7 small songbirds killed per turbine per year, not day, not week, not month, per year. So the oil and gas folks have convinced us that turbines are horrible for birds. Not the case. That's a different issue, but we're working on that and trying to solve that. The other thing we need to do is we need to have more low emission vehicles in the transportation sector. By 2030, we need to have 5% of our fleet be in low emission vehicles. Can we do that? No problem. We're already there. 2050, 35 to 65% low emission vehicles. No problem again. We can do that. So now let's look in the US. Greenhouse gas sources in the US, 28% is coming from the generation of electricity, 29% is coming from transportation, 9% is coming from agriculture. Most of that is from dairy cows and beef cows. Some of it comes from other sources, but the big portion is from dairy and beef. Then we have 12% for commercial and residential, and 22% in industry. Industry is a tough one. This is cement manufacturing. It puts up a lot of CO2. When you're talking about what's going on with melting of steel, the steel companies, this is a tough one. This 22% is a tough one. But there are things we can do in all the other 4 locations. So let's talk about what we all need to be doing. For electricity, we need to be supporting renewables, solar rooftops, wind farms. You need to be supporting them. They are very good. They're going to stop the increase of climate change, and we're going to stop extinctions. We need, if you have a an appliance that you're going to buy, make sure you only buy Energy Star appliances that are highly rated. If you have any incandescent light bulbs, even Christmas tree bulbs, throw them away. You need to be using other kind of bulbs than incandescent bulbs. Incandescent bulbs belong in our landfills. I know that sounds strange, but I really mean it. Transportation, electric vehicles. Make a pact with me today that your next car, when you buy your next car, it plugs in. It doesn't have to be just electric, but it needs to plug in, physically plug in, to be actually using electricity to charge the batteries. And you should be getting about 50 miles for a charge, and most of that will be used for running errands. If you have at least a battery that has 50 miles on it. Now, what do we do about agriculture? Well, we can have meatless Mondays. When I was growing up, my grandmother was a Roman Catholic and she always had fish on Fridays. Well, we can have meatless Mondays. And I put a plus there saying, maybe pick another day, maybe meatless Thursdays too. And if you do have to eat beef, please eat beef that allows birds to grow sustainably. BlueNestBeef.com. I have no stock with them at all. But this is a company that grows beef and in a sustainable manner that allows the grassland birds to survive. And we need to be doing that. Grassland birds are the types of birds that are dropping in abundance, except for albatrosses, the most of any type of birds. Albatrosses are dropping more. But if you must eat beef, then get the right kind of beef. But we can have meatless Mondays. A friend of mine also says she has non-dairy day. She picks a non-dairy meal each day. So she has no dairy and no beef. I'm sorry, I meant no cattle for one meal. So she has no dairy and no beef for that one meal. One meal every day for the whole week. Pick a meal on the day. You can do this. We all can do this. We just have to buckle down and do it. Now, what do we do about commercial and residential? We need to be talking to the developers in our county. We have the developers in Sarasota County are very strong. We need to convince them that we should never, ever build another building that is not zero emissions. We know how to build zero emissions buildings. They cost a little bit more right now. It's going to help us in the long run, I promise. So we need to be doing zero emission buildings. We can do that. We can do that. The other thing that you need to be doing is you need to be decreasing the amount of energy that you're using. So if you have, like I do, a toaster that has a LED board on it that says things to me all the time, that means that it's using electricity. I don't need to know what my toaster is telling me all the time. I only need to know that when I need to toast my toast. So I unplug my toaster all the time. When I want a piece of toast, I plug it in. There's a lot of things we can do that way. Turn your computer off at night. That's another way to save energy. You need to be saving energy. It makes a big difference. I promise it does. Now we have to talk about this. How do we save this 22% from industry? That's a tough one. That's a very, very tough one. And my suggestion is we all need to be planting trees. And there is an organization called cooleffect.org. And you can go on that website and tell them what your carbon footprint is, and they will calculate how many trees need to be planted to counterbalance your carbon footprint. And then you pay them the money to plant those trees, and they go out and the reason I like them is they plant the right kind of trees in the right way, in the right locations. There are many places that plant the wrong trees in the wrong way, in the wrong locations. So I've done a lot of work I promise you that cooleffect.org is a very good organization, and it's going to plant the trees in a manner that will be very beneficial to our world. So this is something that I do for Christmas presents, for birthday presents, for anniversary presents. I go online, I figure out roughly what the CO2 expense is going to be for the person I'm buying a present for, and I offset their carbon footprint by that amount, and then I tell them, and they love it. They absolutely love it. It's a great way to give presents. I really like it a lot. That brings me to this, and I'm sure most of you remember where you were with the very first time you saw this, when all of a sudden you realized how fragile our world is. This was taken on December 4th, 1968. December 24th, 1968. We've known for a long time our Earth is very fragile. It's the only Earth we've got. We've got to take care of it. The point is, we have to take care of it, and we can. It's not an issue of we have to take care of it and we can't. We can. We can make a big difference. All we have to do is get off of our duffs and make that difference. So thank you very much for listening. This gives you my name, my email address, and my phone number if you would like to get in touch with me to talk about this some more. So thank you very much for listening. I greatly appreciate it. And I'll stop sharing my screen now and go. I don't remember who's gonna, I think Linda, you're gonna take the, no, yes, Linda, you're gonna take the questions.
Yes, thank you very much. You are absolutely correct, Terry. The first 3 chapters were depressing, but then you showed that by all means there is hope. And I'm going to join you with those packs that you mentioned. And
Good.
I think there is a chance by all of us taking the right actions. Carol wondered how extensive the use of herbicides and pesticides had a negative effect on the survival of species, especially our pollinators.
Yes, it has been absolutely devastating. It's actually helping to kill the manatees right now. There's a huge problem with manatees dying right and left. Pollinators, the nicotinoids that actually are bred into the plants are killing them. I have a horror story, just a horror story. People went out on my advice and bought milkweed from Home Depot. And it turns out that that particular group of plants actually had nicotinoids in them. And the nicotinoids killed all of the caterpillars. And I had all of these people calling me saying, Terry, why are my caterpillars dying? And so I had to do the investigation and found that you have to be careful where you buy your milkweed. You have to ask if it has nicotinoids. And if they don't know, don't buy it. Go to a native plant store. They're not going to have nicotinoids in them, but it is very bad, and you need to try to not use pesticides. I had a border collie, and I had a gardener that was using Roundup, and I didn't know that she was using Roundup, and I would let my dog out, and my dog came down with nasal cancer and died. That is just one organism that is affected by Roundup. So pesticides, herbicides are horrific. Try not to use them. You can use soapy water. I have a huge vegetable garden. I was canning all day yesterday, potato leek soup, but I use a solution of soapy water and I spray them on my plants, and that's just fine. So there's a lot of things you can use. To get rid of fire ants, you can use vinegar water. There's a lot of things to do. you just need to be, you need to be careful.
Thank you very much. Now, Barbara's wondering because we got Whole House Solar Co-op in 2017. How is FPL making it harder to get solar now?
Well, what's happening is they are pushing very hard for people to not get solar. They want to have solar facilities. They want to be the ones that are actually controlling the generation of electricity. So when I was in California, you would sell back your electricity that you didn't use, and you made, I think these are made up numbers. I think I bought my electricity for 15 cents a watt and I sold it back for 13 cents a watt. Here, right here, we sell back at 3 cents a watt. So it is not helpful to not help property owners make more on their the power that they're generating. And FPL I have a friend who actually FPL is on the the Florida Audubon board. And so I was talking to them, and they really have a policy that they want to control who is generating the electricity. They want to do it. So they're going in and bulldozing these gorgeous, pristine areas that are great for gopher tortoises and putting in solar arrays. I like the fact they're putting in solar arrays, but look at all of the houses all over Florida that could have solar panels on them, and we wouldn't have to knock down all of this pristine area that the gopher tortoises need. So the other thing is that when I put solar panels on mine, they had to come out within 6 weeks to connect me. So they came out in 5 weeks and 6 days to connect me. So anyway, it's been a battle. It's been a battle, but it's worth it. And solar rates have come down. When I first bought this house in 2015, the amount of money to put solar on was over $35,000. When we put it on through the co-op. The co-op is fabulous, and it dropped it by more than half of what that was. So it really, and now I have an electric car. My husband still has a gas car and I have an electric car, and we charge our electric car on it, and that's paying back faster. So I've already paid off my solar panels. I've already made a profit on it. So it's a really good deal.
Fabulous. You mentioned cars, and we're wondering, what can we do to get car dealers to sell hybrid or electric cars? Barbara was told locally that one car manufacturer had a hybrid version of the car she wanted, but that the dealers in Florida would not sell them. There was an excuse that those hybrid car models would only be sold in states who followed the California emissions standard, which we guess that Florida is not. Can you give us a little guidance in those cars?
I know the exact car you're talking about, because when we were on the market for a car, we looked at that exact car, and we would have had to have gone up to, I think it was Maryland. No, that's not right. I don't remember what state we would have had to go to. And then if it broke, we'd have to go all the way back up there to get it fixed. So there was no way I could do that. So we decided to buy a Nissan Leaf. If I'm a very tall woman, I'm 5'11". My inseam is 36 inches. I went and tried to sit in the Teslas. The only Tesla that I fit in was a great big huge one with the wing doors that go up like a bat's, you know. That was a little much for a couple, an older couple without kids. So we decided not to do that, but we went to the Nissan Leaf. Our Nissan Leaf now gets 234 miles to the gallon. More if my husband's driving than if I'm driving, because I like to drive fast. I should admit that. But we have had no trouble with it, except for the fact we want to go on a trip to Colorado, and we determined that we wouldn't be able to go the southern route with our electric car because we couldn't get across West Texas. There were no charging areas unless we had a Tesla. If we had a Tesla, it would have been fine, but we don't have a Tesla, so we'd have to go up to Oklahoma and then come back down. It is changing. It is truly changing. When I got the Leaf, I actually had to get it from Maryland because all the Leafs in Florida were black. And I thought having a black car in Florida was absolutely nutso cuckoo. So I went up to Maryland and bought the car up there and got a white one, which I'm not fond of white, but that's what was available. And I got it. Things are changing. Ford is coming out with a truck, an electric truck. I really do think it's going to change fast. There are some states, and Florida seems to be one, that is dragging its feet. But DeSantis said that he is going to put electric charging stations along the major arteries. We'll see if he does it. I don't know if he will. But right now, you still can do an awful lot. We drove over to Vero Beach to get our puppy, and in the middle of the pandemic, and we had no trouble whatsoever. None whatsoever. Driving an electric car is a real kick. I can beat anybody off the line at a red light.
Thank you very much. Now we've gone over time, and I thank everyone for staying because we have appreciated your talk so very much. There is one last question, and that is, one graph showed China emissions became very high about 2005. Do we know why that is?
Yes, China came out with a huge, big project to electrify its country. And that is a good thing to do. The only trouble is they decided to electrify it with coal. So that is what has happened. The other thing is that America refused to sell China the most recent technology for building coal-fired power plants. So it sold China I think, I don't hold me to this, but I think it was 1945 technology. That sounds ludicrous when I say it out loud, but I actually think that's true. The technology that was so backwards that it emits even more than it should be. So again, we need to be in a more egalitarian environment. If we would just give them the kind of technology that was up to date, it wouldn't be as bad. It would be better for us in the long run. Yada yada yada. It's a tough one. It's a tough one. But that's what happened. Is China really pushed hard to electrify their country, and they did it with coal. That's why it jumped. That's good observation to see that it jumped in 2005. You were watching. Thank you.
Thank you very much. It has been an absolute fabulous presentation. I can tell you that we have all enjoyed it tremendously, and I am looking forward to when we can invite you back to update